Welcome to our tutorial session. Today we will be talking about the Earth Observation Training Data Lab. This is a project that we EarthPulse have been leading for the past year, working also with other companies, EX, Progman, Synergize, and SpaceTech. And this project is funded by ESA. And the overall goal of the EOTDL, when I say EOTDL, is the Earth Observation Training Data Lab, just short, is to provide a repository, an online repository for training datasets and also pre-trained machine learning models. That's on the one hand, something that you can expect to find there. But then also on the other hand, to provide an ecosystem of tools for you to create these training datasets on your own, also facilitate the process of training machine learning models and everything related, okay? So I hope this is useful for your work. The idea is to have some kind of interactive tutorial, not us talking all the time and you listening or watching. The idea is to try to have some conversation as well in order to know your impressions, your needs, and that can also fit to the project to improve it in the future, okay? So, the background of the project, as you can imagine, if you have been working in this field, creating training datasets for machine learning models, especially in Earth observation, is not an easy task. So if you work on other fields, maybe you can scrape the internet for images or text and curate it somehow, and you can build a very big dataset for training models. But in the case of Earth observation, this is more difficult. The data, the images are not easy to find, download. Maybe you need some kind of expertise on the images, especially if you work with radar images. You have to do some processing and so on. And as you also may know, for training machine learning models in a supervised way, at least you need to label these images. You need to create some kind of annotations. And in some cases, this is also very difficult. This is also time consuming. And you may even require some ground campaigns to validate the labels, okay? So the EOTDL fits inside this problem. We try to go to some of these problems and try to facilitate our lives when building training datasets and also training models. So a little bit about the project. Well, I don't think I introduced ourselves. My name is Juan and he's Fran. We both work at EarthPulse. We are a startup from Spain, in Barcelona. And this project started more or less 1 year ago, September 22. We started with a design phase, then the implementation that has been during the last year, well, almost all the year. And we are releasing the version 1 today of the EOTDL, okay? So for us, it's a huge milestone. And let's hope that everything is working and that is useful for you, okay? So the ecosystem of EOTDL, here I have it in words and also a diagram that we can see. The EOTDL is open source, okay? And it's also built on top of open source projects. This is the GitHub repository. You can also find it directly on the website, EOTDL.com. If you click here on GitHub, you will be redirected to the GitHub repository of EOTDL, okay? So we will go over all this, don't worry about it now. Through the EOTDL, you can access data. Right now we are supporting Sentinel data, but the idea is that we are introducing more and more data sources as we see the need from the community, from you basically. So you have now the power to steer this project in the early days. So if you have a particular need, for example, radar data or other kind of data, this is a good time for you to jump in this project and propose new data sources that you would like to work so we can implement them. So we provide tools for creating datasets, accessing this data, selecting time ranges, areas of interest, and so on. We also offer some curation functionality based on stack. I don't know if you are familiar with the stack specification. We will talk a little bit more about this later, but this is the specification that we use in EOTDL. Again, if you prefer to work with other specifications that you think are better, now it's the time to propose it so we can also evaluate that. We have also some engineering tools for feature engineering, labeling, as I mentioned before, quality assurance of the data sets, and also training machine learning models. Since this is an open source project, if again you have some preferred tools that you like to work with, they can be included as well in EOTDL. If you have some complicated workflows, they can also be integrated here so others can use it. So if you think this is an appropriate way to contribute with some of your engineering tools, pipelines, and so on, then you can also consider it. And finally, you can access the EOTDL in multiple levels. We have user interface, we have web APIs, CLI, Python library. Okay, so I don't know exactly at which level you might be more comfortable working with, but you can do it at all these levels, and through this tutorial session, we will discover them, okay? So this is a diagram of the architecture of EOTDL. I am making it smaller, but it's not working. Anyway, okay, these are you. You can use the EOTDL through the user interface. We are also working on some wrappers for accessing the datasets and models through different frameworks, like PyTorch, for example. This UI is connected to the API, which also CLI is connected to. So maybe if you are developers, you can access directly this functionality, this backend functionality, instead of working through the user interface. Okay, and the EOTDL library in the end is composed by the data access module, where you can access Sentinel data through Sentinel Hub right now. But again, in the future, we are looking to introduce more data sources. The data curation part, which works with the stack metadata, and also the engineering part with all tools regarding labeling, feature engineering, training, and so on. So here you can see we also have some additional user interfaces that you can also work with today. And yeah, that's basically it, okay? So, who is this for? And I hope all of you fit into some of these categories. So if you are data scientists or machine learning engineers working with Earth observation data, you can use the EOTDL to create and share your data sets, train your models in the cloud as well, okay? Maybe you are domain experts and want to explore artificial intelligence on your work, then you can also try some of the models that we have on the EOTDL, and yeah, you can explore the models, download them, and try them. Maybe you are a developer and want to contribute to this project. You can create more data sets. You can directly contribute to the code base of EOTDL. And finally, also, if you are a student or a researcher and you want to learn about artificial intelligence for Earth observation, then you can use the EOTDL to download some data sets, train your models, and so on. Okay, so do you fit into these categories? Is someone not represented here? Maybe we should add it as well. Okay, so as I mentioned before, the idea for this session is to have more or less an interactive conversation with you. So we have prepared some Slido polls. I don't know if you are familiar with them. So maybe we can launch now the first one to know a little bit more about your background, which is something that we already have been discussing in the previous minutes. But maybe it's nice to get an overall idea of the population that we have here today. So, yeah, let's launch the first one. ¿Cuál es?
Ya está.
¿Esto?
Sí. Ya la he visto.
Okay, so I would like you to go to slido.com and put this code. Otherwise, if you are already on the Discord server that I ask you to join, then you can find the links directly there. So you can just click the links on the Discord server and go in. So if you can type your background, we will see here, who are you?
Or if you have any questions, you can ask anything here, so we can. It's like a Q&A, live Q&A, so we can see in real time your questions and answer them.
Mm-hmm.
Is it possible to have access to the Python notebook that you're sharing also?
Yeah, I will show you now how to do that. Okay, so we have an AI engineer, remote sensing analyst, science and geoscience, academic researcher. I think you can put multiple backgrounds, but so right now Earth observation and engineer are the most common things. Okay, great. So I think everyone put their background here. We have a bright room, but it's nice to see that more or less what we anticipated is covered here. And again, if you think that some of the things that we are talking about does not directly apply to your work, raise your hand or just interrupt us to know what the EOTDL can do for your work. Okay, so all these answers are saved. Maybe we will share them in the end of the session. Okay, so we have a second Slido that we will launch right now, which is what are your expectations for this session? So knowing a little bit about your background and what I explained you that the EOTDL is, it's interesting for us to know what are your expectations for this. So you can type whatever you want. Creating datasets, training models, access data, or whatever.
Answers are limited to 25 characters.
Okay.
You want to shorten, Chris.
Yeah, that's better.
I have to think of some abbreviations.
Maybe we can put it to 100.
Yeah?
Yeah.
Okay, now it's 100.
That was a quick fix.
Okay, so getting to know the product, pre-train models, learn more about EOTDL, data access, training data, EOData, learn more about EOTDL, creating datasets, what's being done, EOData process modeling training, EOData processing. Okay. Okay, so I see that some of you just want to know about EOTDL in general. So we'll try our best to explain everything. And for the rest of you that have some particular expectations on Earth observation data access processing and so on, as well, we'll try to explain what the EOTDL can do for you. And again, if you feel that something is could be better for your work, then let us know, okay? Okay, great. So, EOTDL, as I mentioned before, is an open source project. We would like to be it also a community-driven project. So if you want to get involved into the EOTDL, with the EOTDL you have a couple of options. The first one that I would suggest is to join our Discord server. I don't know if some of you already are, because I already shared with you the link on email. But for the rest of you, if you are not on Discord, I would suggest you to join right now, because we would like to streamline all the conversation there. So again, through this session, if you want, you can talk there, and we are also monitoring the Discord right now. So if you have any question and for some reason you don't feel comfortable doing here out loud, you can type it there, and we will also answer, okay? And also, the other way is to keep track of our GitHub. In answer to your previous question, you can go there, okay, to the GitHub repository. You can find the link directly on our website. So at EOTDL.com, you click on the GitHub button, it will open the repository. So if you go to the folder called tutorials, workshops, BiDS'23, and here you have the same notebooks that I am showing right now, okay? So if you click on the one that's called 00 EOTDL, here you will find the links to Discord, for example, if you want to join now. Yes? Okay, so let's start with the tutorial. This is what we want to cover today. We will start explaining you how you can explore and download datasets and models from EOTDL. Then we will talk about how to train models locally or in the cloud. Then we will show how to ingest datasets and models into EOTDL. I hope to finish this before the coffee break in approximately 1 hour.
What is the Discord server's name?
Sorry?
Can you go back to the one where I can join in Discord?
Here, this link. If you click to this link, you should be able to join the Discord server directly.
Thank you.
Yeah, it's working?
It's loading. Take time.
Hello.
Sí.
Okay, so if you find any problem joining Discord or whatever, then let us know. It's working?
Yeah, please proceed.
Okay. Okay, and then when we come back from the break, we will show you how to create your own datasets with the tools that we provide, how you can create stack metadata with the tools that the EOTDL has for data curation, and finally how to get involved and contribute to EOTDL. There are multiple ways for you to follow this session. The first one, of course, is to just pay attention what we are doing and take notes or whatever, and then you can run these notebooks at your own pace. The second one is to follow the demos that we are doing live with us. You can do that on your local machine, on your laptop if you want. So for that, the instructions are easy. You can, well, you would need a Python environment on your laptop, so I guess that's something that you know how to do if you plan to follow this session in that way. But you can clone the repository with this link. Then you go to this folder that I mentioned before and I show you in the repository, and you can start Jupyter with the command Jupyter Notebook, and you will be able to just go to the tutorial session with us. Okay? Then the second way to do this is to do it in the cloud. So in EOTDL we are offering some cloud resources. So if you want to do that, these are the instructions. First you go to eotdl.com and create an account. So for that, you just go here, click on the sign in button, and you register, you sign up with your email and a password. And once that it's done, you should see the sign out button on your profile. Okay, this is the way to just sign up. Okay, I repeat it because it didn't prompt for the email and password. If you click sign in, you will then have to click on sign up if you don't have an account already. Okay, and this will ask for an email address and password. And then you just put your email and password on the login, and it should work. You should see here the sign out button and your profile. Okay? So that's the first step. The second step is to go to this URL, hub.api.eotdl.com. Okay? If you go to this URL, you will see something like this. You won't see the second line, you will only see the first one. But I will click on the second one because I need it for later and it can take some time. But you should click the first one, okay? Well, actually, I don't know if I can do this, but I will click the second one. So this will open a Jupyter Lab environment in the cloud. And in order to run the notebooks, you will have to run this command on a terminal. You can copy this directly from the notebook. You don't have to write it if you don't want to. Okay, and this will copy into your cloud workspace all the notebooks that we have on the repository, so you can run them in the cloud. Okay, so whatever your preferred option is, just paying attention, running on your own laptop or in the cloud, you just choose one. We can wait for everyone to be ready, and then we can start. And if anyone needs help with this, let me know, and we can help you set up everything.
Do we have another Wi-Fi, not ACV?
No, I think the only Wi-Fi is ACV.
Oh, there should be an event Wi-Fi.
There's nothing else.
Yeah, it should be the BiDS events. And I can tell the password. It's at BiDS'23, all lowercase. BiDS 2023.
I have a EOTDL account, but if I go here and start my server, it says you have no limited workspace.
Okay.
What does it say?
It says you currently have no activated workspace.
Yeah.
Yeah.
So we'll let you know, our friends at EOX.
Who's next door? Pull Stefan out of the other room.
Yeah, but it's the other one that we need, and he's sick, so. No tienes lo del IT, ¿no?
Desconecta un momento la pantalla, sí.
what does the message said?
You currently have no activated workspaces. You have no tracking.
Activated workspaces, okay. Okay,
Excuse me, my dog.
I suppose the event Wi-Fi is very slow. I mean, the event Wi-Fi.
Yeah.
Oh. I don't know a lot about Wi-Fi's, but I mean, if it's not working for you, do try the event Wi-Fi. It seems to work at least for me.
Yeah.
okay.
No estoy en IT, Ahora estoy en el BiDS', aquí en el EOTDL, pero no en IT. Es un problema aparte.
Sí, te he invitado, pero bueno. Okay, so let's start with the first notebook. You already notified the IT guys, so if they can solve the problem, you should be able to open the workspace, okay? Otherwise, you can follow on your laptop if you know how to. If not, then I guess you have to stick with option 1.
And which workspace were you supposed to open? Because I already had access to the Jupyter.
So you would be were able to open the Jupyter Lab?
Yeah. This one.
Okay.
One more, right?
For me, it's still loading, but once you open it, you should see a Jupyter Lab environment, right?
I do, but was there one more that you tried opening before?
Yeah, that's only for me,
Oh,
but you should only see one option,
yeah, okay.
okay? Okay, so let's start with the first notebook.
Well, maybe it's because I didn't register for this workshop. Maybe they only activated the workspace for the people who have registered with email.
No, this is not the case. I just
Same thing for you.
same.
Yeah, and she didn't register, and she can access.
I did register.
Oh yeah,
Yeah, I did.
oh, you were not on the list.
Exactly, maybe that's why.
That's weird. Okay, so the first notebook is exploring and downloading datasets and model. So this is the most basic function of the EOTDL, which, as you can imagine, is just go to the repository and see what there is, the datasets that we have, the models that we have, so you can access them. So the easier way to do this is through the user interface. As I mentioned before, EOTDL.com. You can go there, and here you can explore the datasets and models available in the repository, filtering by different options. You can edit your own datasets. You can read the tutorials that we have on the blog, which is very similar of what we are showing today. You can read the documentation and find other useful links. So this is the website, the EOTDL. We have here the different sections, home, the datasets. Here you will find all the datasets, also the models, and the documentation. Here we have some recent datasets, popular datasets, a leaderboard of contributors. So right now this is just only to have some information, but in the future the idea is that the top contributors would have some kind of prizes or advantages in EOTDL, like for example having access to cloud GPUs for free for some time. So if this is something that interests you, I suggest you to contribute to EOTDL with datasets and models, so in the future you will be able to have some prizes, okay? And the same for the model section, and some posts here to get you started with the different aspects of EOTDL. So if you go to the datasets section, you will find here all the datasets that we have right now, about 40. The idea is to grow this population to more or less 100 datasets. That's our goal for this project. But of course, if you put there your datasets, more datasets, then we will have more. And you have different filtering options. So you can, of course, filter by name to find some datasets. You can filter by tags. So we have some tags here that you can click to filter the datasets. You can show only your liked datasets, because if you go to a dataset, you can like it. So it's like saving it as your favorites, for example. And then you can also filter by the quality level. This is something that we will discuss later, but you can, for you just to know that the datasets and models in EOTDL are classified into different categories according to their quality, and you can also filter that. Okay, so let's see if they responded. Okay, if you were able to open the cloud workspace like you did, you should see something like this, right? You have this Jupyter Lab environment. Okay, and you can do things. So the first thing that you should do is go to the terminal and copy this command that you have here. So that will copy all the notebooks that I am showing to your workspace. So you will find this folder now called BiDS'23 with all the notebooks. So you can run them. Like, for example, this is the one that we are running right now. Okay? Okay, so once you find some dataset that you like this one, for example, Eurostat RGB, you can go here and you can see the information about this dataset. So the name, the tags that were applied when it was created, you can like it or dislike it, how many times it was downloaded, size, the quality, and also you can choose different versions because we support versioning for these datasets. Some information on it, command to download it through the CLI, some metadata, and also a simple file explorer here so you can check all the files that are inside this dataset. Okay, if you upload a dataset, you will see this edit button on your dataset. So you can click here and change the name, the authors, and all the content information of this dataset, and of course select the appropriate tags.
Is there any limit in the size of our dataset? I don't know if I have 10 gigabyte.
So there is a limit, but it's pretty high, like several terabytes. So I think you should be fine. In any case, if you are trying to upload a dataset and for some reason you are getting some kind of error, then you can just say us something through Discord and we will take a look. Okay, this is for the datasets, and we have the same for the models. So this is quite new feature. That's why there is only one, which I did for this tutorial. But in the future, you can expect this section to grow with more and more models, okay? And the same, if you go here, you will see the information about the model just exactly before, like before.
So on dataset, you support folder structure.
Mm-hmm.
How does it work?
So you have, I will show you this later, but you have a folder in your computer or whatever with your dataset, and with the CLI, for example, or the library, you just say ingest that folder. And then we go there, take all the files, and ingest them here. We also apply some versioning, but we will talk about this later. And the same for the models. The current is not a problem, but it's due to how it's done. If you want to ingest it file by file, so you know all the files that you have, it can be slow if you have a lot of files. So an alternative is just to just create a zip file with everything and just upload that. If you do that, here you will not see. For example, for this dataset, I did this test. So for example, version 1 is just the zip file with all the data. So this is faster to upload and download. But of course here you don't know what you have inside the dataset. For version 3, for example, you upload it file by file and you have all the data, but it's a little bit slower.
Okay, but it's interoperable because now you can access the data as if you need to download it.
Exactly. You have both options.
Maybe you can extract it automatically so that you don't have to.
Yeah, we could do that. That's something that we were thinking but for versioning, it's a nightmare doing it.
I think that's something necessary because I think one issue with these data repositories in general, so I'm not talking about work observation, but in general, they don't support folder structure, so it is not possible to access individual files within the data sets.
So here you
That's a very big problem.
here you can do that.
That's very good actually. That's fine. I mean, it's not bad.
So for example, I don't know if you are familiar with this dataset, the Eurostat dataset, but you have all these folders with some images inside. So here you can see all the structure. Then if you go to the documentation part, you will see all the docs. So how to get started, how to install EOTDL, we will go over this. Authenticate, use the cloud resources, that should work in theory. More about quality levels, we'll talk about this, how to work with the data sets, the models, and so on. So we will go over all of this, but you can use the documentation on your own. Okay, and finally in block.
Sorry, for what concern the models, are there any limitation in the format of model? Because I see only it's
For quality 0 that we say, that's something that we will talk about this later. But for Q0, you can upload whatever you want. Okay, and in the blog you will find also some similar versions of the tutorial that we are doing today, but more general, on how to start with the EOTDL, explore and downloading dataset, which is what we are doing right now, how to ingest and how to work with higher quality level datasets, okay? And also you will find some interesting links like how the link to join Discord, the AI for Your Challenges platform. I don't know if you know this about this project, but it's also interesting if you like competing.
Yep. Regarding cloud resources, you have to confirm your terms and conditions on the EOTDL on your profile. So
Yeah, so try to go to your
profile.
profile, clicking here, and then you will find some checkboxes here that you have to check, and then accept. Okay? Maybe this is what's... I don't know if... Did you do that?
Yeah, I did that.
Ah, okay. Then that's it. I didn't know, sorry. My fault. Okay, so if you do that, then you should be able to open the cloud workspace. Did it work?
Yes.
Ah, okay, great.
Which to do is select.
So now, if you open the terminal, like I showed you before, and copy this, then you will have all these notebooks on your workspace, so you can run them like us. Okay, so we've seen how to explore the datasets on the user interface. Now let's talk about the quality levels. As I mentioned before, we have these filtering options, Q0, Q1, Q2, and this is because we support different quality levels. Q0 datasets and models, they are just a folder with your data, so we don't check anything there, besides some mandatory metadata that you have to put in a file that I will show you later. But then things get more interesting with higher quality levels. Q1 datasets are datasets with the stack metadata, okay? So if your dataset is in the stack format, then it will be automatically ingested as a Q1 dataset. So this enables us to take your dataset and provide some more interesting features on the user interface and other places, like more advanced filtering options and quality metrics, for example. Then Q2 datasets are also datasets with a stack, but not only the basic stack metadata, but also the extensions that we are enforcing for these quality levels. Okay, so we have been working on some stack extensions that you can include in your datasets. So when you ingest a dataset with the stack metadata and these extensions, they can take, let's say, the full potential of all the features that we offer on EOTDL, and we'll show you how to do this, of course, later. And finally, there is Q3 datasets, which are Q2 datasets that are manually curated by us, or at least audited by us, so they can be used for benchmarking activities, for example. This would be the higher quality levels, but of course these are the most time consuming to produce. I don't know if you know the ML Hub from Radiant Earth, which recently I think changed the name. So all the datasets there should be considered Q3, for example. That's why they have not a lot of datasets, but they are high quality, let's say. Okay? So we wanted to support this kind of high quality datasets, but also leave you the opportunity to just upload all your datasets there, because that's also very useful sometimes. Okay, so of course you can also explore and download datasets using the command line interface. This is probably the easier way if you want to train models or something like that. So for that, if you are following the session locally on your computer, I would suggest you to create a new Python environment, because you will need to install some things, and it's easier to manage dependencies like that. So these are the commands that you can use to create these environments in your computer. Otherwise, if you are following the notebooks in the cloud workspace, everything should be installed there, okay? So you don't have to do this. The first thing that you need to do is to install EOTDL. This is very easy, okay? You just execute the command pip install EOTDL, which is commented here. You can uncomment it, and it will install the EOTDL and all its dependencies. Okay, and once it's installed, you should be able to run the command line interface with the EOTDL command. So for example, with EOTDL help, you will see all the commands on the CLI. Okay, if you are not familiar with notebooks, this is just for running this command in a notebook, but if you run this in a terminal, you don't have to put this exclamation sign, okay? What you can do with the CLI, you can log in, of course, explore and download and ingest datasets and models, and you can also know the version of the EOTDL. So this example of the version. For each command, you can also have some help. So EOTDL datasets help. It will tell you what you can do with the EOTDL datasets command, which is just download some datasets, ingest datasets, or get a list of all the datasets that we have. So if you run the EOTDL datasets list, you will retrieve the list of all the datasets that we have on EOTDL. Okay, this is the same that if you go here to the datasets page, all the datasets that we have here, you can retrieve this information from the CLI like this. Some other options, you can filter by name. This will return all the datasets that match this particular string, Eutelsat, for example. And if you change the list command or parameter by the get, followed by the name of the dataset, this will download the dataset, okay? You just type EOTDL datasets get, the name, and it will download it and return the path in your computer where this dataset is stored now. So the EOTDL datasets list command should work. The get one should ask you to log in, okay? You can also log in with the EOTDL auth command, but I just do things, and whenever required, the EOTDL CLI will say, this needs some authentication, go to this particular URL and log in. Okay, so in order to show you how to do this, I think I am already logged in, yes. So you should see something like this. On your computer, go here, you just click here, click confirm. You will have to put your email and password if you didn't before. You go back and that's it, okay? You are logged in. This will save your credentials in this folder. So all the subsequent actions that require you to be logged in will take your credentials from there. So as long as you don't delete this file as I just did, you will be fine.
Okay, but if we spin up the workspace through EOTDL, we're already logged in, right?
You are logged in, but I think this credentials file is not generated. So maybe you have to do that because the workspace and the CLI are two different things, and I'm not sure they are connected right now. And maybe that's a feedback item that we can get.
I got that authentication panel.
Yeah, if you take a long time to do this process, because in order to avoid this having...
It's very short.
Yeah, it's very short?
Yeah.
Okay. So we take note also to increase the time.
And just to know, we have launched a new poll in Slido, so if you want to answer, you can answer at your own pace. Just to know a bit more about you and the tech stack you work with, EOData.
Okay. So if you run EOTDL datasets get help, then you will see all the options that you have for downloading these datasets. So the first one is to tell where do you want to store the downloaded dataset. By default, it will download to a folder in this cache folder that we showed you before, but you can say, okay, I want this dataset to be downloaded into this particular path. You can also specify a version of the dataset. And if you try to download multiple times the same dataset, it will say, okay, this dataset is already downloaded, but you can force the re-download if you want. Then, this is not supported yet, okay, but this will be supported soon. You can access particular files on your dataset, okay? If you just want to download some file, you can use this option. And then for Q1, Q2 datasets, since I mentioned before that they are stack metadata datasets, if you download a Q1 or Q2 dataset, we'll only download the metadata, okay? Because that's the idea of having the stack metadata, not having to access the actual data to do things. But if for some reason you actually want to download the assets of your dataset, so the actual images and so on, you can use this option, okay? This is all explained if you run the help command. So again, this will download to this folder by default, but you can specify a path, you can specify a version, the force. This is what I just explained. For Q1 plus datasets, it will download only the stack metadata, but with the -A option, it will download the metadata and also the assets. And the same for the models. You just change the parameter datasets with models, and it's exactly the same. You can download datasets, ingest them, get a list of all the models that we have on the EOTDL. Okay, so I will go quick over this because it's exactly the same. Okay, so we've seen how to explore the datasets in the user interface, how to explore and download them through the CLI. Now we will see how to do it with the library, okay? This is very similar because in the end the CLI is using the library, so it's exactly the same. But if you are building Python applications, maybe it's more interesting for you to use the EOTDL library instead of the CLI. So you can import EOTDL on your Python scripts, and then from the datasets module, you can import the retrieve datasets function, and this will get you a list of all the datasets in EOTDL. You can pass the name to filter by name. And then here, then of course, you can do whatever you want with this. If you try to download a dataset that's already downloaded, with the CLI you get a message error. Here in Python, you get the actual error. So be mindful if you work with the Python library that you are the responsibles of managing all the errors that the library will throw, okay? It's a little bit more powerful than the CLI, but you have to do more work to build your applications in the end.
On the retrieve command, downloads the dataset, the retrieve datasets. Or does it just list them? You have the up there, you have that.
The retrieve datasets, it retrieves the names. It's like the datasets list command.
Oh, okay.
It will give you all the datasets that we have, just the names.
Okay.
If you want to download the dataset, this is the function. Download dataset. And you can, of course, use the same parameters that we showed before in the CLI. So force a download if it already is downloaded, the path where you want to download your dataset, and exactly the same for the models. So retrieve models will give you a list of all the models, and download model will download the model and return you the path where the model was downloaded. Okay, and the last accessibility layer, let's say for EOTDL, is the API. You can see the documentation here at api.eotdl.com/docs. Okay, this is a fast API. And here you can see all the endpoints that we have on our API for authenticating, for working with the datasets, the models, and so on. Okay, so this is the most complex way to interact with EOTDL, of course. But in the case that you are building your own applications and they are not in Python, this is the only way, okay? So you have to interact directly through the API with all these endpoints and so on. So this is pretty well documented, so you will find examples on how to do all the things. But in any case, this is important for me if you actually want to use the API to build something and you don't know how, the best way is to just go to Discord and start a conversation with us, okay? We can assist you in this process. But if you are building your applications in Python, use the CLI or the library. If not, then you should use the API, okay? So for example, if you are building a third-party application with a user interface, maybe it's a good idea to use the API as well. So this is an example of how you can request the list of all the datasets that we have. Of course, here you have the access to the full information on the datasets, not only the name. So the name, the authors, all the metadata, all the versions, the files, and so on. Okay, and once you retrieve the information, then you can do whatever you want, like filtering, downloading the files, etc. Okay, some calls to the API will require you to be authenticated. So this is the workflow that you have to follow. Go to the auth login endpoint. You will get a login URL and a code. Then you go to the login URL. Then you go to the auth token endpoint to get a token with the code that you get from the first one. And finally, you can use this token in every request for authenticating. So this is also a reason why working with the API is the most complex workflow, okay? But if you already work with APIs, then this is something that you might be familiar with. Once you get your token, you can use it in the header for the requests that require you to be authenticated. Like in this example, download a dataset. Okay, so that's it for this first tutorial. We have two more to do in the following 30 minutes, so we should be fast. But anyway, this is some roadmap that we have planned for this part for the upcoming months and years. Okay, the EOTDL will be working at least for the following 2 years. So these are some improvements that we have planned. First, on the user interface, we plan to improve the exploration of the datasets with more visual tools like maps and filtering options. Then for Q1 plus datasets, we will have geographical and temporal search, okay? So you will be able to filter the files in a dataset using a bounding box or a time range, for example. That will be nice. And also perform metadata queries for Q1 datasets. Since we will have all the metadata, you can filter, for example, if you want all the samples in a dataset which correspond to a particular label, that's something that you will also be able to do with the EOTDL. Okay, so all this Explore functionality will be improved. Okay, and now before going to the next notebook, it would be nice to know more about your ideas on what you've seen, you have been seeing up until now, and also if there are additional features that you would like to see concerning the exploration and downloading of models and datasets. You can do it live or Discord if you prefer, and we can answer. Is this something that makes sense for you? Do you think that something is missing?
You have all the options, so I think it's fine. So
Okay.
your API, your command interface, your code, so that's what we need. So if you want to develop a professional application, then API interface, I guess, as you said, is the best case. And
Mhm.
otherwise, if you are downloading some research purposes, command interface or Python. So all bases covered, I would say.
Great.
How do you position each platform? Because you mentioned Guardian Earth and they have also a similar repository where people are putting
Mm-hmm.
similar data sets. So how do you position yourself in the landscape?
Yeah, so this has to do with the quality levels, let's say, I was mentioning before. So all the datasets that they have would qualify like Q3 if they didn't use our own extensions, but they have their own extensions. The problem is that for them to actually ingest a dataset, it takes a lot of time, okay? It's not an agile process. That's why in the repository they don't have a lot of datasets. Our idea is to open this so everyone can ingest their datasets without having to ask permission to them specifically to do that. So it's a more open platform for that.
Comes a bit the price of the quality, right? Because
Exactly.
This Q0 means just a dump. So basically, the usefulness of data can be questioned
Mhm.
significantly, right?
Exactly. These are the trade-offs that we
Yeah.
make.
There's the trade-off. And partly, if we go to that side, then basically people can use a standard data repository as well, like Zenodot, for example.
Mm-hmm. I don't know if the ML Hub is using Zenodot. I don't think so.
But we're also coordinating this activity with Radiant ML Hub and
Mhm.
Source Co-op, as they're called now. So they actually have a small consulting role here also to ensure that we're not developing anything that's contradicting or too much redundant, you know, so that these things
Mm-hmm.
interact.
But in the end, you have the choice to work with Q0 or Q1 or Q2 datasets. So if you value a lot this quality aspect, then you should ignore all the Q0 datasets. But for example, for a lot of people, it's very useful to have a repository where you can just put your dataset in a zip format and being able to get it from all your pipelines. That's very useful as well. Okay, so let's go to the next tutorial. I think we'll go over this very, very fast because it's not the main point of this session, but if this is more interesting for you for some reason, let us know, okay, and we will expend also some time talking about this. And it's training models. So the idea is that now you have explored the EOTDL, you have found some data set that you would like to use for training the model, and this is an example of on how to do that. So if you work with Python, for example, in this case, we are going to train a model with PyTorch Geo library. You can just put these two lines here, and it will download the dataset that you want from EOTDL import download dataset. You will download the dataset that you want with the name to a particular path. And once this is downloaded, you can now use this dataset for your own pipelines. Okay, so as I mentioned before, we are using the PyTorch Geo library. This is an open source library built on top of PyTorch, on PyTorch Lightning. I don't know if you're familiar with these frameworks, but the idea is that on top of this framework, we can build what we call the wrappers, which are just, in this case, Python classes that can get the dataset from EOTDL and prepare it so you can just use it on your workflow, okay? So you don't have to worry about extracting the data, preparing the labels, and everything. So on the PyTorch Geo library, we've implemented this wrapper, and here you can specify where the data is. Of course, you should use the same path used here, where you download the data, and other options like the batch size and everything. Okay, so this will prepare your data, give you some information. In this case, it will just generate the list of images and the label. In this case, this dataset has 10 classes, the Eurostat dataset. And here you can visualize some of the samples. Okay, these are Sentinel-2 images, and the task is to classify the images. So for each one of these images, our model should tell us, okay, this image corresponds to an industrial area, this image contains a river, and so on. Okay. So on the PyTorch Geo library, we also offer what we call tasks, which are just, again, some classes that has everything to train, let's say, a neural network for the image classification task, so you don't have to do that, okay? We instantiate the task. In this case, we have to tell what number of classes that we have, and that's it. We can just pass tensors to this task, and it will spit some predictions, okay? In this case, for each image in this batch, which or a probability distribution over the 10 classes, okay? For training these models, we use PyTorch Lightning. So you instantiate the trainer with some options, like using 1 GPU, how many epochs should train, and this is just for going fast, okay? If you want to do this seriously, you should delete these 2 lines. Okay, this will train the model, in this case, by default, a ResNet model with 11 million parameters. And once this is trained, here we are evaluating the accuracy in the test. As you can see, it's very low because it's a fast example. We encourage you to try to get something better. And here we are just visualizing some of the predictions that is getting right in green and wrong in red. So once you have your model trained, you can ingest it into the EOTDL. In this case, before we are exporting into the Onyx format because it's better. I don't want to get into details on this. It's not the goal of this talk. But in this case, we are exporting this model to the Onyx format. We are checking it's working like before. I also encourage you to do this. It will save you a lot of time when things are not working. And finally, you can ingest this. I think I forgot the cell to ingest the model. You should, no, because this is explained in the next notebook. Okay, as I mentioned, this is not the main purpose of this talk, but I wanted to give you an example how to take a dataset from EOTDL and ingest it directly in your training pipelines, okay? So I think we had a slide here, right?
Yep.
Because this is also something that it's interesting for us.
We are in another event in the second one.
What's that?
This one.
Okay, so we would like to know what are your machine learning, deep learning framework of choice? Because as I mentioned before, we are implementing these wrappers. Right now we have on the PyTorch Geo library, but if you work on other frameworks, it's also interesting, so we can implement wrappers for that. While people is writing their solutions, this is also something I wanted to let you know. If you go to your cloud workspace, you can, of course, train models here. Okay, the problem is, as you may imagine, in order to do this efficiently, you would need some GPUs. Okay, so I opened this session in a GPU virtual machine, if you saw at the beginning, but you don't have this option. Of course, we cannot provide GPUs to everyone for free. So if this is something that you want to have access to, what you have to do is to go to the Discord and ask us, okay? So in the phase that we are in the project, we are able to provide some GPU resources up until some limit. But in the future, we will have some mechanisms for you to earn credits, let's say, to do this, like ingesting datasets, models, labeling datasets, and so on. So some sort of gamification feature that we will add, okay? Or directly purchase it, of course. If you want to just buy credits, you will also be able to do that. I think this has a GPU you can work with. Okay, so we have some PyTorch TensorFlow. Okay, that's great. Okay, so we had on our roadmap to implement some wrappers for PyTorch, but I see also people still works with TensorFlow, so.
There's another library called Keras. I'm not really expert on this, but is it still used as an alternative for PyTorch, or how do you assess it?
Well, the new version of Keras works with PyTorch and TensorFlow, so it's not an issue right now. Yeah, it's a wrapper on top of PyTorch TensorFlow. I think it also supports JAX, so. In fact, you could have the wrappers in just pure Python and then have some second level wrappers for PyTorch and TensorFlow, and then it will automatically work with Keras. Okay, great. So we have 10 minutes for the next notebook. But I think this is also important. Yeah, I think this is also important, and if we can do the next tutorial maybe in the next blog very quickly. Okay, so I would like you to respond to these questions, okay, either live or through Discord, because this is very important for our future roadmap, okay? Mainly, what are your needs in terms of training data sets and training machine learning models with EO data? So maybe we can have a 10-minute chat around this, or maybe if you want also to stick around in the coffee break, we can talk about this, and then we can continue with the next tutorial. Okay, so yeah, if someone wants to share, what are your main problems?
Well, I think the main problem I have in my experience is like the lack of data that you can get, because maybe there is not enough data to train deep learning models, because you really need a high amount of data. So it's difficult sometimes to be able to generate a good reference data sets to be able to train these models. So also it's more expensive also in language models, in like that. I don't know if you are familiar with Hugging Face, that they have like pre-trained models that you have to make time. Let's say you have to make like small configuration in these models to provide to your own for your own goals. So maybe that's also something that is useful for us, that having like pre-training models to be able to work with that so it will be easier to get better results. So.
Yeah, so the main idea here on EOTDL for the models part, at least, is to have exactly this. So we only have one, but we would like to have a lot more. And for example, let's say that you want to do some image classification on Sentinel-2. I just chose these tags because it's the only model that we have. But it will narrow the list of models, so you say, okay, maybe this is useful. And here there is no description, but it should have something with some instructions on how to run this model, which kind of inputs and outputs you need. So you can, okay, I get this model with this command, or download it through here, and I can just put it in my pipeline. Okay, it works, it can go into my application. No, then you can continue looking for other models.
Okay, so in the end, you are like looking to do something similar to that Hugging Face interface that, I don't know if you are familiar or not with that they have this kind of a lot of, so you need time to be able to have that like that list of models there, but
it's not exactly the same, because in Hugging Face you have to rely in their models, in the transformers library. Okay, so if you don't have the source code of the model, let's say you can't run the model. But in this case, for example, if in the Onyx, in the ONNX format, you don't need that. Okay, so you can just download this model and you can run it even in other languages. Okay, this doesn't require even Python. So, but in the end, it's because I uploaded this model in this format. If I would upload a model in a different way, then in the description I should say, okay, to run this model you need to do blah blah blah, or maybe just a link to a repository with a notebook to run it or something like that. It's useful to have. But this is the idea for the models section. To have this repository of models that you can just filter and put in your applications.
That's great, because sometimes you lose a lot of time only the training to make the parameters fit in your, and if you have already one that make your problem easier, it will be better.
Great feedback, thanks. So anyone wants to share their challenges in their current work?
Actually, I'm working with, for example, change detection or detection in time series data, so it's not an easy task, for example. But I'm totally agree with the guy, because the most important thing in this moment is to have some pre-trained models, because, for example, if you work with the very high resolution data, it's not so easy to train this data, because are very huge data, and you have to manually, I don't know, create bounding box, for example. So also if you have training set, you have to buy a lot of computer resources to train your data. So the challenge in this moment is to have a repository for pre-training model from what is my experience.
Okay, so models over data right now. Maybe we should put more effort in that part.
Yep.
Anyone wants to share some challenges you're facing? Do you think EOTDL could help you with?
If not in Slido, you have another poll talking about your main pain points you can face when you work with AI for EO, so it could be also great for us to have this feedback.
I have a general question, if I may.
Mm-hmm.
Could you, I mean, this is all really interesting and nice, no? But when I look at your GitHub page or on your website, it all looks nice, but my question is, I mean, how big are you? How sure can I be that your group or your company exists in 5 years? If I go with this platform, or if I do this, how sure can I be that it's a long-lasting platform?
Mm-hmm.
That if I adapt my workflow and so on to this kind of models, data platform, Python notebooks and so on, I mean, how long is your funding? And
Yeah,
say a
so
little bit about this. I mean, maybe 1 minute elevator pitch kind of thing.
the first thing that I would say is that this platform is not from EarthPulse, it's from ESA. We are just building, but
Yes, so how long is
So I can say
funding?
ESA is the owner.
So I'm the technical officer that initiated this project. So we have this initially as a 3-year activity, which is already longer than typical ESA projects go, but the long-term perspective is really important because we know that users will be hesitant to adopt a technology if they don't know how long it will be around, right?
Okay.
So, and one already said it's open source, so even if EarthPulse disappears in 2 years, we would somehow make sure that it prevails. On the other hand, also we're, as ESA, ESA EOP doesn't really provide a system for handling training data, so actually for us also is the hope that we can integrate this somehow into more operational framework, no? So one example right now with OpenEO, for example, OpenEO platform, which we've been supporting for the last 4 years, and now we have CDSE, Kubernetes Data Space Ecosystem, where there's a full OpenEO backend, no? So we're pushing this technology into kind of a long-term sustainable future. And the same thing here, and I think one thing that Juan and colleagues are also trying to do now is to link this also to Destination Earth,
Mhm.
Destiny. So if we're actually already thinking about things that in Destiny no one is really thinking about. So if we push it in there, then the technology will spread, and it will then be a little bit less dependent on EarthPulse, but it's more like building an ecosystem
Mhm.
that uses that technology.
Okay, so it's more than just another startup which is trying to fill up a niche, but there's more
Yeah.
funding in the background.
Yeah, I mean, well, there's more ambition, and certainly we're trying to have this not to be just another project or not just another platform, right? I mean, but how we do that in Europe is always a little tricky. But certainly that's one of our objectives.
Yeah, it's open source, and also we want to manage this as a community-driven project. So in the eventual case that for some reason the company disappears, the code is there, and it's just for someone else to go and take ownership. And we use it internally also, so it's for us important to keep it alive as well.
ESA is the owner anyway, right?
Mhm.
So eventually we have an owner. Actually.
Well, at the moment, in fact, it's not owned by ESA. We're supporting industrial consortium to build this, but the ownership is with industry right now. However, we also have the network of resources, which is kind of a sponsoring mechanism that we have in place in UP to also support the premium tier, for example. So we're planning to release a premium tier of EOTDL, where you will have premium access to GPU resources. This will be sponsored by ESA, free of charge for any pre-commercial user, but it will also allow and create a revenue stream for the consortium. So,
EOTDL is already mentioned in several calls actually. So there are some ESA projects which are specifically asked to use the
well,
platform.
sure. I mean, we're trying to foster reuse in different activities.
Yeah.
Like in Destination Earth now, I hope that we find some
sorry that the discussion now goes in a different way than it was intended.
Okay, so now it's officially coffee break time. So you are free to go grab a coffee, or if you prefer to stay here and talk with us, you can do that, and we will resume in 30 minutes. Okay, so let's continue with the next notebook, and now we will talk about how to ingest existing models or datasets to the EOTDL. Again, the easiest thing I would suggest you to do if you want to do this is to use the CLI. If you remember, we will have the EOTDL CLI datasets command, and now instead of get or list for retrieving all the datasets, you can put ingest, okay? Like that, you will be able to take your dataset on your machine and ingest it into the EOTDL. So here you have some options. The first one is the path. You should specify where your dataset is. Also, you can put the verbose option to have some prints on the way. And another requirement, I think it's explained a little bit later. Here we are going to do the example with the data in the workshop data folder. And inside the workshop data folder, there is this Eurostat small dataset that I created just with a couple of images for doing this fast, okay? So if we wanted to ingest all this folder as a dataset into the EOTDL, the first thing that you need to do is, if you want to ingest it as a Q0 dataset, you should have this metadata file, okay? It's mandatory to have either this or a catalog.json, which is the stack convention. So this is the only two options that you have to ingest a dataset. If you put a metadata YAML file, this will be treated as a Q0 dataset. Okay, and inside this file, this is the things that you need to put there, mandatory, at least right now. This is something that is evolving, so maybe in the future we decide to add more mandatory fields or less. So you have to put a list of authors, the license of the dataset, a source link, and the name of the dataset. Okay, and this is the name that we will use then on the platform. Okay, so whatever you put here is what will appear here as the dataset name, okay? So some restrictions that we have on this name. It should be a unique name. So if you try to ingest a dataset and you get an error saying this dataset already exists, you should change the name, okay? Because we don't allow multiple datasets with the same name. And then other requirements on the name is in the documentation. I think we also put it here somewhere. Just so it, yeah, here in the documentation of the CLI. Okay, it has to be between 3 and 45 characters, that only alphanumeric characters and dashes are allowed. So if you get an error saying that the name is not valid, then you have to stick to these requirements, okay? So no spaces, for example. Okay, so now that we have this YAML file in the root folder of our dataset, when you call the EOTDL data ingest, pointing to that folder that contains the YAML file, it will take everything that's inside that folder and ingest it into the EOTDL. Okay, you will see some progress bars doing things, and once this is done, if you now call the list with the name of your dataset, you should see that in fact now in the EOTDL there is a dataset with the name that you used for ingesting your dataset. Okay? As you can see, this is very easy. So if you already have some folders on your computer with datasets, you can just go create this metadata YAML file, put your name as the author, some link, the name, and ingest. Okay, and all your datasets now will be there, and you will be able to retrieve them from any pipeline with the functions or the commands that we've seen before. Exactly. So I don't think it's here. I think it was here. But once you ingest the dataset, for example, this one, as you can see, you don't have any description, you don't have any keywords, you don't have anything. So what you have to do if you want to apply all of that is to go to your dataset here in the user interface, click the edit button and put all that information. So this description, these tags and so on, you can put them here. Maybe for you it makes more sense to do that directly from the metadata YAML file.
So basically, I think you create a kind of divergence between the metadata and the metadata that you store in the system, because the metadata YAML file will be different from the metadata that you edit.
Yeah, if you come here and edit this file, then the metadata on your file would be different, of course.
No, because metadata is part of the dataset, so you store it.
The only thing that should be the same, let's say, is the name. Because if you change the name, it will change or your local or the uploaded part. But yes, in fact, there is this divergence, of course.
Maybe it's better that you don't save metadata YAML file. You just take it while ingesting, and after putting that data in your database, don't store it, because it doesn't make sense to store it.
Mm-hmm.
And you have only one copy of metadata.
Yeah, it makes sense. Okay, thank you. Okay, so this was for ingesting Q0 datasets. For ingesting Q1 plus datasets, you would need to have the stack metadata, so you would need at least one catalog JSON file. I don't know if you are familiar with stack metadata, how it works and how it's structured, but if you are not familiar, then what you need is a catalog JSON file. It's like the entry point for any stack dataset. So you can do the same for models. So here I have this model that I trained in the previous notebook. I can create a folder, copy that model, create the metadata YAML file, in this case with the name of the model, the author's license and source link, which is the link to this notebook. And once that's created, I can ingest with the EOTDL models ingest and pointing to the folder with the model and the metadata. Okay, so we have the same problem that you mentioned before, and in fact, you can ingest a model, you can ingest a dataset as a model if you are not careful. That's also something that could happen. So in the end, we have this trade-off of low friction ingestion, but at the cost of putting the less checks as possible, for example, for lowering this friction in the end, which is important. So if you have any opinions on this and you think that we could do something to improve it, I would like you to get in touch through Discord or GitHub issues or whatever, and put, hey, I think this is not good, I would prefer to have this in this way, blah blah blah, and then we can say, okay, this makes sense, we can change it and implement it.
One question regarding ingestion. So let's say you have a dataset which has 25,000 images.
Mm-hmm.
So what happens if ingestion breaks down after uploading 10,000?
Yes, so if you ingest it file by file,
Yeah.
if you do that through the CLI, you would have created a dataset up until the failure,
Yes.
and then when you try to upload again, it will create a new version, and it will continue from where it broke. This is how it's implemented. If you use the API, then you would be able to manage this however you want. But with the CLI, which is the recommended way, this is how it works right now. If you ingest a zip file, it would do the same. But for zip files, we actually have a way of tracking how much of it has been uploaded, so we won't start from the beginning. But a new version will be created, I think, anyway. So, talking about versioning, this is something that we support by default, so you don't have to do anything on your own to version the datasets. Okay, if you have a folder with your data and for some reason it changes, like you add more images or you change something, then it will be ingested as a new version. If you try to ingest the same thing twice, it will say there is nothing new to upload, so it will not upload anything, okay?
Everything fine?
Yes, thank you. So this means that when you download a dataset with the EOTDL datasets get, you can choose which version. So this is important because if you have an automated workflow and you are working with some dataset that can change because you change it or you are making it in a collaborative way with some colleagues and these versions change, then it's important to set the version that you want to work with. Otherwise, it will always download the latest version, which is what you may want or not. Okay? So this means that on the folder that you select to download the dataset, you will find multiple folders with the number of the version. Okay, we don't only apply versioning on the dataset or model level, but also at the file level. So if you ingest multiple versions of one dataset, but some files in those datasets don't change, then we know it's the same version of them. So we have versioning at these two levels. But this is not something that you have to worry about. Okay, so here I am creating a new file inside this folder, and I ingest again, creates a new version, and uploads the new file and the existing files. It's not uploading them. It's just telling the API that these files should be assigned to this new version, but it's not uploading them. Okay. So this was ingesting through the CLI. Ingesting through the library is very, very easy, and it's exactly the same because in the end the CLI is using the library. So from EOTDL datasets, now you can import ingest dataset or ingest model and pass the path to the folder that you want to ingest as a dataset or model. Okay, the same applies. You need the metadata YAML file. It's exactly the same. And if you don't change anything, it will say that no new files are detected, so it will not upload them, which is here the case because I run this a lot of times during the preparation of the notebooks, and I have all these datasets already ingested. And finally, ingesting through the API, I would not recommend this in any case because it can be very complicated. These are more or less the steps that you would have to take to do that. Okay, you would have to call the API to retrieve or create a dataset, depending if it's a new dataset or it's a dataset that already exists. Then you would have to create this new version for the dataset or the model, and then ingest the files. We have some different ingestion endpoints, depending if you want to ingest small files or large files, because they have to be ingested in different ways. For small files, you can ingest them in batches to be a little bit more efficient. So you don't ingest it one by one by, let's say, 10 in chunks of 10 files. And for large files, you have to create a large file upload, let's say a multi-part upload, ingest the file in chunks, and then finally complete this upload. Okay, and if you don't want to ingest files that already exist there, when you retrieve the dataset and all the files, you can check which files are already there. So you can optionally not ingest them. If you do, the API will already manage this in the proper way. But you can notify the API saying, this file in this dataset, I want you to add it to this new version, but I am not ingesting it because it already exists. Okay, it's a little bit complicated. Maybe it could be a little bit more easy, but this is how it's implemented right now. So I don't recommend using the API if you can just use the library or the CLI. But if you need this for your applications, again, get in touch with us in Discord and we will help you with anything you need. Okay, so this is everything for this part of the tutorial. Maybe a couple of questions that we can have a quick chat about. Concerning the ingestion process that I showed you before, do you have any comment here? Something that you would like to see that you are not seeing? Maybe also concerning versioning.
Yeah, if you make a mistake about the ingestion, is there any way to delete?
So we don't support, I mean, it can be deleted, not by you. You have to say me, I want to delete this dataset, because in the future, this platform, well, in the future and now, let's say that you upload a dataset and I build a pipeline on top of your dataset. If suddenly you delete your dataset, you ruin my work. So we don't allow the deletion of datasets. But if you make some mistake, you can write me through Discord and say, please remove this dataset, I made a mistake. And then if I see that you created it today and no one downloaded it, then I can delete it. But anyway, what I suggest to you to do, in the case that you ingest some dataset and for some reason it's wrong, you can change the name and re-upload it, so it can create a new version. Maybe version 1 is not useful, but maybe version 2 or version 3 is what you intended to do in the first place, and that will work as well.
It might be really tricky for you to manage. There will be many people who will make mistakes. That's very clear.
Mm-hmm.
I think maybe it's better not to take that responsibility. Just let people play.
Yeah, the problem is that what I mentioned, if I'm using a dataset that another person did and that person decides to delete it, then
But you should track this, so you should somehow track that a dataset is in use, and if the dataset is in use, you shouldn't let it, right?
yeah. So if no one downloaded,
Maybe not download, but maybe people can indicate, because actually I think the importance for this kind of platforms is, of course, you are facilitating people to access data, but you should be able to also monitor who is using the data, right? So there should be some mechanism in place for you to do that.
yeah. So we know when a user ingests, when a user downloads, we track all this information.
Exactly. So, and based on that information, maybe we can limit some actions. For example, deleting a dataset. If it is downloaded for a certain number of times, or I don't know, you can put some limits, but not letting people delete something will become an issue for you as an operator.
Okay. Yeah. So that's something that we can do. Maybe put a criteria of number of downloads, and maybe if a dataset has more than 10 days and 10 downloads, it cannot be deleted or something like that.
Makes sense.
Mm-hmm.
It could be also that you how to say, shift this responsibility towards the users. And for instance, you have information. If I have ingested some data already, then I will know how many users this data set has, or maybe list of data sets that was used, unless there are not millions of them.
Mm-hmm.
And on the other hand, if I use some data, maybe it would be good to have information that all the data sets that I used, is there a new version and why? For instance, maybe there was a mistake and someone wanted to include something which is also important for you. So it's good to know that there is so you are like, okay, it's on the users. If you want to keep using the version which was not perfect, responsibility of the user.
So, for example, when you upload a new version, putting some kind of message or to track the changes or something like that. Okay.
And also disseminate it among the users so that they are all aware what's happening with their data sets and they are building something.
So maybe receiving an email saying a new version of this data set.
Yeah, I don't know how, but it could be like, yeah, it's true. It's how it is done. It's another.
Okay, I think that's also a nice idea.
Or you can put it in this metadata description of the data set.
Hmm.
Yeah.
Okay.
I have a question actually. Because I understand there are millions of tools that you can use for that purpose, but do you have anything like, of course it depends also on the purpose that you are using the data, but do you have like a recommended or suggested framework for projection, or that if you want to use different data sets, and it would be nice and convenient to have it all projected in the same way and just put it together.
So for Q0 datasets, we are more or less leaving to the user the responsibility of this.
Okay.
But for Q1 datasets, Q2 that they commit with a stack, the stack metadata has a projection item.
All right.
So you know exactly all your data, the projection. In fact, in the future that we want to add more filtering options, you will be able, in fact, to filter inside the same dataset all the data with this projection.
Okay.
So you can put that in your pipeline. Okay, so let's go to the next tutorial. In this case, we will be talking about how to create datasets from scratch using EOTDL, and Fran will take over this notebook and the next one, and I will be here asking or answering questions, okay?
Okay, so I guess this is the fun part of the tutorial, because we're going to create, as Juan said, a new dataset. So we're going to explore how to download the data, curate the data, and then creating a stack and ingest it on the EOTDL. So we are going to cover the entire end-to-end process, like starting from the data access to the data ingest. In this way, well, we have already prepared it like an area of interest. In our case, we have selected the Bodaya Reservoir, which is in Catalonia, in Spain. It's a lake we are used to work with, so it seemed to us a good example. So let's start with this. First of all, we're going to do like a bit exploration of the data. So we are going to use LeafMap. I don't know if you are used to LeafMap. LeafMap is a pretty nice library to visualize geospatial information on notebooks. So as I said, we already have our area of interest or GeoJSON. What we are going to do here, it's really simple and straightforward. We are going to read the GeoJSON. We are going to get the centroid of the GeoJSON. Later we are going to know why, and simply display it on the widget. As you can see, it's an easy and nice way just to visualize information. You can add rasters, you can add whatever you want. So it's a nice library for this kind of purposes.
Maybe it's worth noting that we want to build a dataset for detecting the water in this reservoir.
Yeah, so the goal is to create a dataset that we will be able to detect the water mask, the water on the dataset. So we are going to label the dataset, we are going to show right now how to do it, and then generate the stack and so on. So as I said, it's going to cover the entire process. So when created AI datasets, it's usual to work with a fixed resolution. So the EOTDL already has tools for that. So we have some functions to do that. So you just have to pass a centroid and give the pixel size, resolution, and so on. So we can get a patch of 512 per 512 pixels with a fixed 10-meter resolution. So we can create this bounding box and create these patches to download data on it. But it's pretty easy just to get the function, run it. And if we want to visualize it here, it's the same. So we have here our patch, the patch we are going to download data from to create our data set. And it's a fixed resolution, so we can work with it in our AI data sets. So we are going to talk now about the data access from the EOTDL. So we have some already, we just have implemented the access to Sentinel imagery. So we have, with this you can access to the supported sensor. We have Sentinel-1, Sentinel-2, and DEM data, so the digital elevation model. And in order to make it more straightforward, we have already a list of dates, so we can look for these dates. We know there are images, ready to use images on these dates, so we don't have to look and search for a lot of images in a big time interval. So as I said, we have all this already in the words of data, you can access it. So just as a demonstration, we have here, and we have some dates with ready-to-use images. And that's important to say that under the hood, this is important because for the data access to Sentinel imagery, we use Sentinel Hub. What does it mean? We need credentials to access this data. So under the hood, the EOTDL, when you log in, it manages your Sentinel Hub credentials, so it creates account for you. And when it downloads your credential, it stores the credential locally. You have already there your credentials, so the EOTDL manage everything. So you don't have to worry about your credentials or about the data access.
If you go to your profile, when you check the terms and conditions and accept it, now you should see all your credentials that have been created automatically for the different services that we use on the backend, like GeoDB and Sentinel Hub. So you can copy them and use it for whatever you want, or you can just trust EOTDL that it will get this when it needs it. There is a couple of gotchas here. If you already had a Sentinel Hub account with the same email that you use to register now in EOTDL, you won't be able to retrieve this. That's because how Sentinel Hub works. We are already trying to solve this, but this is an issue, okay? If you already had an account, you won't be able to see your credentials here, and then you should do what he will explain you right
Yeah,
now.
if you already have an account on Sentinel Hub, what you have to do is it's pretty easy anyway, is you have to go to your profile dashboard on Sentinel Hub, and there you can copy your credentials, and you have to create a .m file and put them your credentials. So it's pretty easy, and if you are not logging it, neither you have your credentials in a .m, the EOTDL will warn like, you don't have credentials, you must provide them, you have to log in or provide the credentials if you want to access data. So in this way, the data access is managed by the EOTDL environment with a little work by the user if he or she already have an Sentinel Hub account. So this is the fun part. We have several functions to explore and download data. First of all, we can search for Sentinel imagery in our bounding box and in the time interval. Just as a demonstration, we can get the first and the last day to create like a big time interval and check how many images we have. Just a demonstration. So we have the IDs of the images, the date time, the cloud cover, some metadata properties about the images. And if you also want to know how many images we have in this time interval, it's pretty easy to manage. So what we see here is that we have decided our area of interest, and we have managed to create the bounding box we want with the fixed pixel size and resolution, and we have did a bit of exploration about which data we have in this area, and in time interval we have decided.
This is for just one area, but if you want to create a massive data set for a lot of areas, you just have to repeat this process for each area that you want. You can provide it as a list of centroids and create these bounding boxes, or if you already have the bounding boxes, just work with them.
Yeah, something that I've missed before is that once you have the bounding box with the fixed resolution and so on, the EOTDL also have some tools to generate a polygon from this bounding box, so you can, it's pretty straightforward just to convert the bounding box to a polygon, and you can store it as a GeoJSON and cache it locally, so you don't have to save the bounding box in memory, so you have as a GeoJSON, and it's pretty simple, but just to make sense that the EOTDL manage all this kind of filtering and data filtering, so you don't have to go outside and use another tools. Okay, so we'll jump to the download. We have some implementations for this case. It's pretty easy. On the one hand, we can easily download a single image. We just have to import the function. So you can try it if you want. You have uncommented. If we get the first date, we give the output path, so we have to give a path where we want to store the data, the date of the image, the bounding box, and the sensor. It's pretty easy if we want to. And we look for it. That's it. It's really simple to get a Sentinel-2 image. It's a TIFF, it generates a TIFF with the name is simple, the sensor type, and the date, the acquisition date. And we also generate, the EOTDL also generate a metadata file, which is useful later for the stack generation. So you have the acquisition date, the bounding box, and the sensor type. Just like because when you download data from the Sentinel Hub, sometimes you miss some information like the acquisition date and so on. So it's like a way to store this metadata and make sure that we can use it.
And also
later.
to standardize between different data access services. So in the future, if we add more, then we have this common metadata representation.
Yeah. Another way, if you want, you say, hey, I don't know in which days I have images in my area of interest, you can simply use this function, search and download. So you give a time interval and it will download any images available in the Sentinel Hub. The drawback is that you cannot control the quality of those images. So it will download everything and you then must control and curate those images. So for this workshop, if you want to download the data, we recommend using date to date. Is slower, but you make sure that the images you download are correct. So we already have all of these images here in Sentinel-2. But if you want to download, maybe we can download 2 of them. As I said, it's a bit slower than the bulk function, but it works anyway.
I don't understand if this download the entire time that intersect the bounding box, or it is able to create a sort of mosaic inside the bounding box. So,
Yeah.
Yeah, please.
I mean, it just, you have the bounding box and it just the image you get is just the bounding box. So if it's a big bounding box, it creates a mosaic from all the images it finds in Sentinel Hub and create a single image.
Okay.
It's fair, but that something happens. Yeah. No problem. Sometimes it crashes. And well, we can see here we have already downloaded our images, as I said. Here we have formatted the name, because if we go to here, this is like the convention we use to download data with the sensor type and then the acquisition date. We can also look for the metadata files. But in order to make it more straightforward and to kind of label the images, what we do here is simply to rename all the images to give the name of the area of interest. So that's pretty easy. What we do here is simply change the sensor type by Boadella. So all the images we have here have the name of the AOE and the acquisition date. Pretty easy. It's just a way to easily work with this. Okay, so we have downloaded the images that we conform our dataset. And what we're going to do now is to prepare is the step of data preparation. So this is a final step towards creating our training dataset. And there are a multitude of tasks that can be performed here, like data cleaning, feature engineering, data analysis, and so on. And what we are going to do is leveling right now. So we have developed and implemented for this purpose Scaneo, which is a leveling tool that allows tagging images to identify whatever you want, to level and to perform any task you want. So in our case, what we are going to do is to level the water, to have the water mask for every image, and then create the dataset and train the model with it. So Scaneo is simply a Python library also, like EOTDL. So before running the interface, what you have to do is to install it through pip. We have already done it, and it's pretty easy to work with. It's also a CLI, so the main way to work with Scaneo is to launch Scaneo is through the CLI. So here you have several options to run Scaneo, to run this web interface, like the port where you want to launch the web, the host, the data path to the folder where all the images stored, the images, environment, and so on. So we have several options for Scaneo. If we want to simply launch it, we have here. Simply write the folder we have it. And this is Scaneo. As we said, this is a web interface, so you can easily label your images. Whatever image you have here, you can simply put them and check them. Some of them already have the watermark, and we can perform it in several ways. There are some tools that we can use here. As an example, we can delete it. We can draw, as we said first. What we want to do with this dataset is to extract the watermark from and to label the watermark. So it's simply a straightforward way to just draw. You can drop it, erase. ¿Cómo es para hacer más pequeño? Okay. Well, so you have several options to draw the watermark, but what we prefer here to use is we can use GeoSam. I don't know if you are familiar with it, but it's a model to segment images. So kind of one image. This image doesn't have any label, so if we give some ground points, it will use GeoSam to automatically create the mask. It can take a bit depending on the image, but at least what we are going to get is like the perfect, or at least a good water mask automatically generated by GeoSam. So, yep, we saw here.
So it is using SAM to generate?
Yep. Yep, it's integrated, so we don't have to draw. We in the case we can go back and regenerate the mask if we want. The points are already stored, so we can regenerate, we can change them. And for any image of our data set, we can level it and generate the water mask. And when we have it, it's just save.
And this is also editable. So
yeah,
if you come back to the segmentation tool, here, see this one. So this mask that has been generated is, you can edit, you can delete it, and if, for example, it's missing some part, you can improve it a little bit. So to do these fine adjustments in the end.
Yep, and if you click save, what it generates at least is simply a GeoJSON in the original folder.
Right now this tool works by pointing Scaneo to a particular folder, so you can download a dataset from EOTDL and label it if it's not labeled. If you create your own dataset, you can label there and then ingest it. But what we are working on also is to kind of a plugin or integration with EOTDL. So instead of pointing a path, you will point to a dataset directly on EOTDL with the name, for example. And then Scaneo will talk directly through to the EOTDL API. So you will be able to label datasets on Scaneo on EOTDL without having to download any data. So 100% cloud-based, let's say. So that would be a very good way also to collaborate on data sets, and because labeling is time consuming, so if you can have a lot of people labeling the same data set, it's also one thing that we want to achieve with this tool.
Mm-hmm. And if we want to create more labels, like, I don't know, maybe land, we change the color so we can get another, this land. We can create a new level. It's like we can create all the levels we want. In this case, as we said, it's just for water mass detecting, but if we want to separate it by water, land, building, whatever classification we want to do, we can perform it with this.
And you can paint like this, you can draw boxes, and you can also assign tags to an image. So for the entire scene, you want to say, okay, here we have a river, so you can also have that. Okay, and all these labels are stored in a GeoJSON file that you can ingest directly into the EOTDL.
Yeah. Along with the images, we have the labels. Like the name is the same as the image with the suffix labels. And what we have here is simply like GeoJSON with these labels, and at least at the end we have properties labels and the label we have. So our labeling is stored. The geometry of a label is stored here, and we can ingest this through the EOTDL. If we can stop there. Okay. So we said we have several labels stored here as GeoJSON, and once our data is ready, we can ingest it with the EOTDL. So like we have seen, what we just have to do is to create a metadata file with the authors, listen, source, name of the data set. We create this metadata file and we can ingest it through the EOTDL. So,
and if for some reason you have like 1 hour a week of labeling, every time you label, you run this, it creates a new version, and the new version has the new labels. So you don't have to worry about creating versions and so on. You just label, and whenever you are happy, you re-upload the data set.
Yeah, so if you add more images or level to the dataset, you can re-upload them and have a new version of the dataset with the new labels.
And also one interesting thing about the labeling tool, which is in our roadmap, is right now this assisted labeling with the SAMGeo package. It uses that model, which is quite good, but we would like also to enable using any model from the EOTDL. So you would be able to choose which model from EOTDL you want to use as an assisted labeling tool. So this would enable active learning as well, which is a goal for us in this project. So you can at the same time improve a model and a data set. You create some data, train a model, use that model to create more labels and correct the wrong labels, train the model again, and do this iterative cycle 4, 5, 6 times until you have a very good data set and a very good model.
Yep.
Okay, what is your timeline for this? So
2 years.
2 years.
But I guess it will be sooner than that.
Okay.
Because it's also very important for us.
But Scanio, is it part of EOTDL or not?
No,
It's
no.
your product, right?
This is a labeling tool
Yeah.
that has integration with EOTDL.
Okay.
If you have your labeling tool, you can also implement the EOTDL integration, and we will put it in the list of supported tools, for example.
Yeah. So what we have done here in this notebook is to create our own Q0 dataset. So it doesn't have any stack metadata. So it's just the images and the labels. So it's a Q0, and we have ingested in the EOTDL. So in the following notebook, what we are going to do is to create associated stack metadata, create the Q1, add the ML extension, that it's something that we are going to explain later, and create a Q2 dataset and ingest it also in the EOTDL. So as Juan said, our roadmap here is to continuously improve and enhance the Scaneo tool. So any functionality or bug, something that you find and you want, we appreciate any contribution to it. So anything you find here, it will be highly appreciated. And arrived to this point, we have created some questions about, well, I think we have already talked about them, like what features concerning data would you like to see, and so on. So maybe it's time for a bit of discussion if you find something useful to share with all of us.
I have a question to this. The points you selected on the lake, they also stored?
No.
For this SAM, is it this segment anything?
Mm-hmm.
Okay.
The points you mean when we create the GeoSAM? Yeah, they are not stored. They are stored on the fly, so if you...
No, the prompt is stored.
Ah, yeah? Okay.
So if you close the tool and open it again, you will see those points.
But, okay. Mm-hmm.
So in the GeoJSON file, if you would explore carefully, you would see labels for classification. So you will have like the list of tags, the list of bounding boxes, the multi-polygon for the drawing thing, and then the prompts.
Yeah. But, okay, maybe to store the points somewhere else would be also useful.
To import these points, you say.
Yeah, because if I label 5,000 images and I click a million times and then these points are not stored somewhere.
Yeah, that's something that we have already thought about it. It's like storing those points, and for every image, like let's say we know that the watermark is always more or less the same, so we can store those points, and for every image, run the GeoSAM with those ground points. It's something that we have thought about it and we want to implement.
I mean, the segments have more value, that's clear, but to lose the points would be silly somehow.
No, the points are stored, but I understand your point of reusing the points that you draw for one image to all the images.
Yeah, you never know, yeah, but maybe it's useful.
Okay.
But it's a nice tool. Can I also use it in another project, or just in connection with?
No. It's a standalone tool.
Standalone.
You can just pip install Scaneo.
Okay.
You point it to a folder with a bunch of TIFF files, and it should work.
Yeah.
It also works with stack. So if you have a stack catalog, you put it to where you have the catalog, and it will label the data using the label extension.
Yeah, maybe it's worth to say that we also have the documentation page. If we run it, so we have documentation for Scaneo. We have the getting started, the interface, so how to use Scaneo, how to launch Scaneo. Interface. So we have some videos here about like a small, brief tutorials how to use it. So anything you need. But any doubt you have, of course, you can ask in Discord, and we'll be glad to ask you or to help you in whatever you find.
This is not open source, right?
No.
Well, I mean, it's not. So basically, it's your own product. You have the copyright over it. So basically, I think people should run this for using.
I mean, you can install it, and you can explore the code, but it's not open source.
Okay.
¿Qué otras preguntas había? Yeah, so I don't know if this workflow that we have shown you of exploring data, downloading data, I don't know if you have any comments on that, any ideas, other data sources that you would like to see besides Sentinel-1, 2, and digital elevation models. Do you use any other labeling tools? No? Okay, so we can go to the next notebook then.
Yeah.
No, we are using something simple in QGIS.
Mhm.
Yeah, different people can work at the same time. They're just taking a data set, label, and then it gets written to the database. So it's very basic. But this seems nice.
Yes, so you can also, we don't want to get a lot in detail into this because it's not also the point of the talk, but you can start scanning or pointing in a cloud bucket. So if you have your dataset in a cloud bucket, you can have a lot of people labeling your dataset, just providing the credentials to the cloud bucket, and anyone would be accessing that data and labeling that data instead of a local folder.
Okay, so we are going to the almost the last one. So in this step, what we are going to do is we have already downloaded and curated our dataset, or created labeled our dataset. So what we are going to do is to curate the dataset, to push it from Q0 to Q1 and then to Q2. And to do that, we need to create the stack metadata. So something what we have missed is that we have created another event from the, well, as another Slido event. So if you want to ask something, we have created also this Slidos, this poll related to a stack. So we will be glad to, if you answer it, we will drop some polls related to a stack, because it's something that really interests us, because, starting from the beginning, stack, I suppose most of you are familiar with it, but a stack is like a specification and metadata convention to describe not only describe the images, the EO data, but also to share it. So it's the convention that the EOTDL follows, and it's a standardized way to expose, host, and ingest and access those geospatial collections, and the EOTDL has been implemented using this implementation. So, but we don't know if you work with other metadata implementation and so on. It's useful for us if you explain it.
So all of you use it every day? Or maybe just the one person that answered this? Okay.
Actually, I'm using data with stack, not create stack for data. So probably the answer is I never use it.
So I created a stake catalog for references to Kubernetes. So not use it as a client. So basically, same like brick audit interface.
Okay.
So you have used stack as a way to access the data.
I provided a server catalog for the community so they can access it.
Mm-hmm.
From that, working with the native product like this is safe format, so we are extracting information from these and making the catalog available.
Mm-hmm. Okay. So maybe we can continue to the next poll. So we have another, but well, we can wait a bit if you want to answer it. So we said it's very useful for us to know which specification or conventions do you use and implement it later on the EOTDL. So we have another poll related to what other metadata formats or specifications do you use. So this one maybe we can let it in background and continue with the tutorial. So if you have generated a stack, it's a bit painful because generated from the beginning can be, it's verbose somehow, so it can be difficult to generate a stack catalog of collections for your entire dataset. So what we have tried to do here is to simplify the process of generating this stack metadata associated to the EO images. So we have the first thing we have to understand here how we have implemented this translation and this generation of stack metadata is that we work with what we call the stack data frame that at least is nothing different than a pandas data frame. So it's just like the name we have gave it to it. So the stack data frame is like an interface between the dataset and the images themselves and the stack metadata. So with some variables that we can give to this generator, we can customize the stack metadata we want to generate. Like we can add stack extensions, we can define which collections we want to generate, we can label it, and we can add, we can extract. So if you have a Sentinel-2 image with, I don't know, maybe you want to extract the RGB bands as separate files, you can do it with this implementation. So we have several assets for a single item, but that's something that we're going to see here. You will see a lot of text, then it can look scary, but don't worry, we're going to dive into it because it can look complex somehow at the beginning, because we wanted to give the user freedom to customize the metadata you want to generate, but it's pretty, once you get how it works, it's pretty straightforward. So what we have here is, this is the typical stack data frame we can get from a dataset. So we have the path to the images. This is the label, like then this is somehow sometimes the images already are labeled in the name, or it's like a way to differentiate and to define every image. So this is a label we have generated for the images. We have the collection. By default, it put all the images in a single collection that we call source. But if you want, you can define and say, at least this is a data frame, so you can customize it whatever you want. You can filter, you can query, you can search and say, hey, for these images, I want to go to this collection, and I want this extension, and I want to extract these bands. And maybe you have in the same folder, I don't know, if you have mixed Sentinel-1 and Sentinel-2 images, you want to use different extensions. Like for Sentinel-2, you want to use the EO stack extension, and for Sentinel-1, you want to use the SAR extension. So this is a way, if you are familiar with data frames from pandas, this is a way to customize the final dataset and stack metadata we are going to generate. So this is something that I already explained, like the columns and how the data frame looks like. And if we want to generate this metadata, first of all, what we have to do is to import the stack generator class that we have in the curation module. And this class has several parameters. They are, well, we are going to explain them. First of all, the image format of the images. Maybe you want to use PNG or TIFFs or whatever, you have to define the image format. Then the catalog type, this is something related to a stack and PyStack, which is the Python library to work with the stack, that as we work in the EOTDL, all the packages by default are going to be self-contained. It's like a way to define the catalogs. You can have a self-contained catalog with all the relative paths pointing to the assets, the images, or whatever. You have an absolute catalog, relative catalog, but as I said, this is by default the self-contained, which is the preferred options to work with the EOTDL. Then we have the item parser that it defines the strategy when you work with. What we did here is we want the user to be able to work with several directory structures. So maybe you have on your root folder, you have all a single image in every folder where the name of the image will be the name of the folder. It's like some datasets like the Sen1 flutes. I don't know if you have worked with it. It's a structure like that, so it's a way to use it. The preferred way is to use this parser. That this strategy at least is just how the EOTDL has to know which is the item ID. So the preferred way is to simply get the name of the image, and that's it. These are some examples of how the root can look like for any item parser. Then the asset generator, if you work with the stack, you know that the images can have associated assets, like as I said, Sentinel-2 can have an asset for every band, like the B1, B2, B3. So maybe you want to extract these bands from the original image, or maybe you you don't want to. So we have implemented 2 ways to do it. The default option doesn't extract anything, so you have the original image and you don't do anything, or you can extract the bands you decide in using the bands as a generator. That's something, as I said, we want to give you freedom to generate and customize the stack metadata that you generate at least. And the last one is the labeling strategy. As I showed before, here we have this label. Maybe if we have a dataset like maybe Eurosat or the dataset we have created, the dataset is already labeled, like maybe it's river 1, river 2, river 3. So you can use the label strategy to get the label from the name, or if you say, hey, those images are not labeled, I have labeled them with Scaneo maybe, or my tool or whatever, you can use the unlabeled strategy and simply it will take as label the name of the image. So knowing this, we have prepared this for you. So, and we have already selected which are the preferred parameters for this use case. So then we don't have to worry about anything. So if we run this web and we generate the start data frame, it will look like this. So all the images in our dataset with the label, the collection, and the extension bands are set to none because we haven't done anything. And that's the key of the label column. Can also help us to somehow define those extensions and bands for every image. So if we have the labels, we have just a single label, which is Bodega, but maybe we have Sentinel-1, Sentinel-2, or we have building, river, forest, and so on. So we can take the label to specify the extensions and bands, or maybe collection we want to every image. So here we can do is to define the stack extension we want to add. So that's something that's managed by the EOTDL. Maybe you want to add the EO stack extension or SAR stack extension. Those are the support extensions we have right here, right now. So, well, and we have to define, okay, we just want to extract or to define the RGB bands from the Sentinel-2. So with a simple dict, we can generate it. We say, hey, maybe source collection is not okay for me. I want to give another ID for the collection. So at the end, if you run this with this defined collection, extension, so on, we have this data frame with all the information we need. We have the image paths, the labels, the collection we want to generate, the images to the project extensions, and the bands. So we go here, we generate the stack metadata. That's kind of, I'm going to here hit. And that's all. We have generated the stack metadata for our dataset. If we go here, we have defined it at stack2. And what we have is a catalog with the collection we have defined, with all the items we have defined. So if we go here, we can, for example, see this. We have the stack extensions that we have defined, like the EO extension, the projection extension. We have some metadata related to the EO extension, like the constellation, the platform, the bands. We have defined it like the RGB, have some common name, description, coordinates. So it's like an easy way. This is the asset. So this is the path to the original image. So we have all in a single catalog. We have all the images and the stack metadata in the same folder with a common link. This is about the raster extension. So this is we have tried to simplify the process to add extensions and to generate the stack extensions to your metadata. There are a lot of extensions you can use, like, I don't know, I think there are hundreds of extensions, like cubes or so on, so you can add whatever extension you want. At the moment, we have just implemented 4 of them, but this is a case of contributing, so if you want, hey, I need to add my own stack extension, you can contribute and create your own support extension here in the EOTDL. And that's it. So we have our data set with the stack items. But now what we want to do also is to generate a collection with the labels we have generated with Scaneo. And what we can do now is to generate this collection and link the labels to the GeoJSON with the labels, and also link the labels to the original images. So in this way, we have implemented two ways to label items. So you can use the image name labeler, that it's what we had showed before, that if you have maybe a dataset that's a river, forest, or whatever, it just takes the name and those labels to create this collection. And we have this on an implementation for Scaneo. So this is simply for here. This is a Python class that you can use it's managed and it's implemented for label generated with Scaneo. So it's pretty useful and straightforward to to download the dataset, label it with Scaneo, and then generate the labels collection. It needs some parameters, pretty easy, like the catalog we want to add the labels, the root folder where the labels are stored at, like the Sentinel-2 folder we have. Where is it? Here where we have the labels and some extra level properties that maybe we want to add. So if we run this, what we have already generated, what we have is this catalog with also a labels collection. And what this label collection has is the labels related to the labels we have done before with Scaneo. So we have here, this is another stack extension, which is called label, which is the main goal is actually that. It's to have those labels and classify them. So we have the collection, the classes we have generated, description, we can add methods, tasks, and so on. And at least what we have, this is the link to the original stack item that pointed to the image. And this is the link to the original GeoJSON that stores the labels. So everything is managed by the EOTDL, and this is an example of a Q1 dataset. So what we can do now, once we have our dataset with the images and the metadata with the labels, is simply to ingest it in the EOTDL. So this is somehow how to push from Q0 to Q1, generating the stack metadata and then generating this labels collection. Everything good till now? Some question before we jump to Q2? I know it can look somehow complex, but that's because a stack itself is complex to manage. You have several tools like PyStack or other libraries, but the stack convention is somehow difficult to enter it and to work with. And we wanted to give you freedom to generate your own metadata catalog, so it can look a bit complex at first, but if you jump into it, you will find that it's pretty good.
And go back to the catalog you generated.
Yep. This one?
Yeah, the labels.
You want to look to some specific file or?
Just the links, so can you show the links?
In the item or?
This is the updated version of the original catalog, so it includes everything in the original catalog plus information about the labels. Is
Yeah.
correct?
Mm-hmm. Yeah, so one collection is the collection related to the images.
Yes.
This is the collection related to the images with the items, every item point to the original TIFF or image or whatever.
Yes.
And then the labels is related to the labels themselves. So these items, on the one hand, point to the original stack item, which
Is the source. So
is the source.
It is only the label catalog. So
Yeah.
it's the catalog of the labels, but it refers to the original image. So
Yeah.
Okay.
You have the link to the original, not the original image, the original item that links to the original
Yeah,
image.
yeah, yeah.
But also you have the link to the asset with the label,
Yeah.
which is a GeoJSON or a TIFF.
that's what we were talking before about the self-contained catalog. So all the information, assets, and whatever are contained on the catalog, so you don't have to go to another sources. So it's self-contained, and you can simply go to the EOTDL and download whatever dataset and whatever quality you want, and you have all the information self-contained. You don't have to look to other sources.
Yes.
And then when
You don't need the original catalog to create this, right? It's not necessary because this doesn't tell you.
this is done from scratch, yes.
Okay.
If you already have a catalog, then you will not need this step. You would jump directly to the Q2 generation, because if you already have the stack catalog, we already consider it a Q1. You may want to add the labels. In that case, yes, you could do some part of this.
Yep. So now we can jump to the Q2 datasets. That's the, if we go back to the quality levels, as we have seen, Q0 are datasets with stack, Q1 are datasets with stack metadata but no quality assurance, and Q2 are datasets that have the EOTDL custom stack extensions, which is called ML dataset, and automated quality assurance. So these stack extensions have useful information associated to the training dataset that we are going to see. So the EOTDL itself has the environment to create and to add this extension. We have a lot of parameters because we can, if you want, you can simply add the extension and this extension, well, I'm going to show it later, but when you create this, when you add this extension, you can split your dataset between test, training, and validation. So you will have a list with the dataset, and every item will be in some split, and you can do it directly with it. So you can, here simply you have to define the catalog where you want to add the extension. If you want to save the catalog to a new folder, if you want to generate the splits and the label collection, so this can by default it's labeled, so we support it, and some extra information about the extension, like the name of the dataset, the task for the dataset, like segmentation, classification, whatever, the inputs type, annotation. So this is kind of record information for this extension. So if we run this command, what we get is a Q2 dataset. If we go to the catalog, we see that it has those new features like the ML dataset name, the tasks. We have defined the inputs type, the splits, and this is something that we are going to see now. That's we can not only add this extension, but we can also pass like a QA quality assurance. So at the moment we have implemented two methods, which are to look for special duplicates and to create a classes balance. So that's something that we have implemented right now, but we in the roadmap is to implement more quality assurance methods. So what we have here as the dataset is for a single AOE. It looks like it has special duplicate. That's because it's a single image, a single AOE area of interest. That's something we can jump up. We have the classes balance, like all the labels are related to water, but if we have, maybe we have water, we have land, we have whatever, we have like a percentage and a classes balance of every labels. And that's it. So this is kind of information related to the dataset that when we want to share it, when we want to use it, it's important to have here.
And you can generate these metrics before ingesting the dataset in case you want to do some kind of exploration. But this quality assurance pipeline, let's say, it's computed on the API automatically when you ingest a Q2 dataset. So even if you don't do these metrics, we will do them automatically in the same way that we do versioning. So then from the user interface, for example, you will be able to see on a Q2 dataset the balance of the classes, if it has duplicates and other kind of interesting information concerning the quality of the dataset, which is something that we cannot do with any other dataset because we need that special metadata that we ourselves compute when you ingest a dataset with stack.
Yep, and as I said before, you can, when you create those splits, if we go to the collection with this extension, we can see that it has selected all the items and they have defined in a split. So we have all those items are in the training split. These items are in the test or validation split. So this is a way to have a traceability of which item pertains to every split. So validation, test, or training. And that's it. So once we have added this stack extension and passed the quality assurance metrics, we have our QA dataset and we can ingest it to the EOTDL, and that's all. So we have created a dataset from downloaded the images to labeled it, curated it with a stack, and then upload it to the EOTDL to ingest our dataset in the EOTDL. So we jump from Q0 dataset to Q1 to Q2, and that's the entire process to create our very own dataset. This is something that we have in the roadmap, that's support for Q1 and more models, improve the extension as I said, with more quality assurance metrics and so on, improve tools for generating and working with stack metadata. So maybe we can simplify the process to generate these stack metadata associated, or to add more stack extensions to the EOTDL, like as I said, Cube, or any stack extension that you can find useful, and use a stack to filter datasets based on, by geographical, temporal criteria, or metadata criteria, and so on. So that's the finish of this part of the tutorial, which has been to create our own dataset. So, as in every notebook, we like to discuss a bit with you about which features we like to see in the EOTDL concerning to that curation, or which metadata could be useful for you for your datasets. So we are 10 minutes left. Maybe we can jump to contributing.
Okay, so this will be very, very fast, the last one of the notebooks. And here you will find all the information that may be interesting if you want to contribute to EOTDL. Okay, like we mentioned in the beginning, this is an open source project. We want to manage it as a community-driven project. So we have the Discord server as the main point for discussion. So if you want to get involved in any way, just maybe asking for features, that's something that you might be interested in, then I would suggest you go to the Discord server, get into the forum, just write things and kickstart conversations, okay? And the second method would be to just go to GitHub and put issues. Like, for example, I want new data access for this particular data. So you can put there an issue, and we can see how to manage it. If people outvote it, then it can go into a release or something like that. So let's say that you want to contribute. There are multiple ways you can do that. The first one, of course, is to just ingest datasets and models. So if you work with datasets and you already have some datasets, or maybe you work with datasets that you have not created, but they might be useful for other researchers or yourself, because having a cloud repository where you can download the data from, it's very useful. Then just go to the EOTDL and ingest them, okay, using the CLI library, for example. That would be a very nice contribution, both datasets and models, okay? We have a list of models that have to be ingested. So maybe if you don't know any dataset, but you still want to contribute, you can go here to the list of issues, and with this label dataset, okay, here you have a list of datasets that we want to ingest. Okay, this use case are something that we have to do, but the other ones are public datasets that you can download from the original source and re-upload to the EOTDL. But okay, it's easy as that. So you have here a list of datasets that we want to ingest. Okay, the second thing that you can do to contribute is to work on third-party applications. So as you have seen, the EOTDL offers different entry points that you can leverage for building your own thing. So here's some ideas that ChatGPT gave me when I asked for possible third-party applications to build on top of EOTDL. And for example, you could build your own third-party repository. So the same that you are seeing here, you can think, okay, I'm a better web developer, I will build a nicer repository. So that's something that you can do. You can just query datasets from the API, display them here, and when the user click, download them, for example. You can build visualization tools or dashboards on top of the datasets, since you have access to all this information and the stack catalogs, for example. You can build AutoML platforms, for example. We are trying to do something similar with the labeling tool that we showed you before, but maybe you can also do it in your own way. You can build your labeling tools, of course, maybe educational applications, model interoperability platforms, and maybe even, why not build a subscription service on top of EOTDL, okay? So these are just ideas for third-party applications. And finally, of course, you can contribute to the code base directly to the EOTDL. For that, I would suggest you to join Discord, since we are going to manage all the project there. So we will plan regular meetings, okay, to discuss the features that we want to release, and we will plan them into a release, assign who is responsible for developing, testing, and everything. And that would be my suggestion if you want to actually contribute to the code, okay? Here I have some instructions on how to run the EOTDL locally, if that is something that interests you. So the first thing that you should do is clone the repository. You would obtain something like this, okay? This is the EOTDL in the main branch, so you will have this. In case you want to start the API, there is this Docker Compose file that you can just run to open the API. It will start a MongoDB database, mini of our object storage, and then the API with all the credentials for developing. Okay, you will also need an environment file with some data, which I will not show, of course. Some Auth0 clients, some Auth0 keys that we use for authentication. And then we use also UX for some of the things that if you need them, it might be problematic. So in the case that you want to actually develop your own version of the API or improve the API and you need some of these, then you should ask us directly through Discord how to manage this, okay? So, if you want to change the CLI, for example, the code is inside the EOTDL folder, okay? The API is inside the API folder. And here you actually have the code for the library and the CLI. So you can go there, explore it. And this is important. If you are working with the CLI locally and you want the CLI to communicate with your API locally as well, instead of our production version API, be sure to export this environment variable so your CLI talks with your API instead of our, okay? And then you can just change the code, and I suggest you run the API, the CLI, sorry, with this command instead of EOTDL. You can run Python EOTDL main to run the CLI locally while you are developing it. And the same for the library. You export this variable and then you change the library however you want. And in case you want to work with the user interface, this is a SvelteKit application, so you can go there and see the documentation. The code is inside the UI folder, so you go here, just type yarn install to install dependencies and yarn dev to open the application in a development environment, okay? And also in the M files, you will need to put the Auth0 keys and also the link to the API. So if you run your API locally, put here the local host and the port. If you put here API, our URL, the api.eotdl.com, you will be talking with our API. So it's just full stack development. Okay, and just to close, these are the third-party services that we are using right now, the O0 and EOX Hub. And EOX Hub in turn is managing Sentinel Hub and UDB. So in case that you are developing and you need something related with this and you don't know how to manage, then ask through Discord, okay? If you have to take something from here, is if you want to do something and you don't know how, ask us on Discord and we will help you, okay? Great, so that's everything on our side. This is all that we wanted to talk about. We have 4 minutes left, so I think we can call it a day, or if you have any question last minute, then we'll also be happy to answer.
What's your plan with these catalogs? Because, okay, you are creating the catalog becomes part of the dataset, but it is inside the dataset, right? So how will you make it accessible?
So when you download a dataset with a stack catalog, you only download the stack catalog.
Yes.
And then there inside you have the link to the assets that you can download afterwards, or with the -A option in the CLI, you will do that at once.
Yes, but that's local. So eventually that catalog includes a lot of useful information, especially when you add this label information, etc., right?
Mm-hmm.
So will you provide a user interface where people can be able to search for it?
Yeah, of course. So here in the datasets, for example, if you go to a Q1 or Q2 dataset, for example this, right now there is the same information that for the other datasets, but we know this is a Q2 dataset, so here we will be able to put more advanced filtering and exploration options based on that stack metadata.
Okay.
I have a question.
Mm-hmm.
Maybe it was also fast for me, but so inside these data sets there are images, right?
Mm-hmm.
Or stack catalog, which refers to the images. Before we have, in the other example we have seen that you created labels, but also in a stack catalog. But labels don't appear here. So why don't you have another column, datasets, models, and labels? Because labels could be also...
The labels are part of the datasets.
Are part of the dataset. Okay.
So on your dataset you have your image and your labels as well.
Okay.
Inside the same package, let's say.
Okay. Good. Okay. Then that makes sense.
I think it's a good idea. Actually, as the platform, maybe you should have a little bit more control over the data sets that are there and all the catalog information that is inside. So because you can extract all that information
Mm-hmm.
and make it available to others, so people can search for labels, for example, directly.
Mm-hmm.
But you need to extract that information from the data set.
Yeah, so here in the datasets page, it's our idea to put some advanced filtering options. I had it before and I took it because since it's not implemented, I didn't want to put more things. But the idea is to have an advanced exploration option to being able to do precisely this.
Yeah, but it requires catalogs to follow a certain protocol. So
Mhm.
basically, I think you should have some measures in place
Mhm.
while accepting the data sets to check if the catalog that is inside is properly formatted.
Yeah, exactly.
Yeah, so it's something you have to do. Otherwise, you cannot. I mean, people can tell that it's a Q2 level data set, but maybe content-wise it is not. So you should
No. The fact that a dataset is Q2 is not up to you. It's up to us. When you ingest the dataset,
Yes.
we say, okay, this is Q1, Q0, or Q2, depending on what we find inside.
How do you check? Just the existence or
No, we check
the quality?
we check the metadata.
Yeah.
If it has our ML dataset extension with what we are looking for,
Yes.
it's Q2. If not, it's Q1. That's the main.
That's how you define. But it's your different. That's your classification.
Mhm.
It's not part of
No, 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 no.
specification.
No,
it's
no, no, no.
yours.
Yes.
So okay.
So we participate in regular meetings with the community because this is a hot topic right now, and
Yes.
we are trying to converge to a solution. But this is something that from the stack people that they find appropriate, but it's not it's not part of a stack or any specification yet.
Okay.
This is very much a work in progress.
Okay. That's interesting. So then why are you willing to make this a validation test and training?
The splits.
Yeah.
Hmm.
Why do you want to do that splits? Because that splits you can create many number of splits like.
Yeah, exactly.
Character of the data.
This is optional. It's something that you can choose to do or not. But for example, for the challenges, we participate in the AI4EO challenges platform, for example.
Mhm.
And for challenges, you want like the training, validation, and test sets to be always the same for everyone. So you have to define that in the dataset catalog. And in fact, if you want to do some benchmarking datasets, for example, this test data actually has to be hidden. So it's something that no one has access to except for us. That's also a reason for these splits. Yeah, there are a lot of nuances when you get in there that in the end require a lot of workarounds. Okay, so if there is no other question, I think we can close the session here. We have another thing to show you that may be of interest, but that's up to you because we're out of time. So if you are interested, it's just something that we are developing in EarthPulse that I think it may be useful, but now it's out of this tutorial session, so that's up to you, okay?
What's that?
If you want to know, you have to stay. It will be just 5 minutes, I promise.
Go ahead.
Okay, great. So, at EarthPulse, we are developing a product. It's called SPY, Satellite Processing by Artificial Intelligence. This is something that we've been developing since we started, but it's been closed because it's like our own software that we use for building the things that we sell, which is analytics in the end. And we are now looking to open it to developers and the community.
Just if you're entering a confidential phase, you're still being recorded.
It's okay.
Okay.
And we want to open this to everyone. So what is this? We know that building AI4E applications is complicated. We need resources. Data is fragmented. There is a lack of a framework to do that. So this is more or less the problems that we are trying to solve with SPY. Again, this is something that we've been developing internally. We are now opening to everyone. So by the beginning of next year. What will this enable to do? Reduce the time that you need to develop Earth observation-based applications and also make you more productive in the end. What this means in terms of features, we will provide some simplified data access for Copernicus services data, Sentinel data basically right now. Also data processing with your own algorithms or also our AI models through our API. We will also provide some storage layers so you can work with local data in the cloud, databases without you actually having to set up or know anything about that. And SPY will also enable you to build APIs, user interfaces, and deploy all of this in the cloud with some simple commands, okay? So you don't have to provision your cloud things or anything like that. This is more or less the same that I mentioned before. And how does it looks like? Okay, so you can install SPY with pip install SPY, and this will provide you a library and a CLI to do some things. So Here on the right, you have an example of a SPY project. You have a folder, in this case it's called Getting Started. Inside that folder you can have APIs, notebooks, scripts, and user interfaces, okay? So you will build your APIs, scripts, notebooks in Python, even your user interfaces with Streamlit, for example, but we will also support JavaScript-based user interfaces. And the idea is that if you put your code, your application code in this format, then we can run everything with SPY run and the name of your project, and we can take that and deploy it in the cloud with SPY deploy and the name of the project. So we ask you to write a small configuration file, as you can see there in the end. So we know which services, which scripts maybe you want to just run once or just every day, for example. Which APIs do you want to auto-scale, for example, or just have a single machine to run on? Maybe which APIs do you want to run on GPUs? So we can take all this information and provision the cloud and deploy your application there. So this is an example of a script that downloads data. So as you can see from SPY, you can import the storage layer to store things there. You don't know if this is a cloud bucket, this is local, this is a database. We manage all that on the back end, yeah. Then you can also explore and download satellite images with the abstraction layers that we show here. And in the end, the idea is that you focus on your application code. You don't have to worry about where the images come from, where this application will be running, and everything. So we also have some layers for doing things like computing a water mask. The same, we offer you a function from SPY, import water mask. You don't have to worry which data, you don't have to worry about the algorithm. We do that. Of course, if you are interested in the algorithm and the data, this is not for you. If you are just interested in the application that you can build on top of it, then it's very, very useful to just call a function and have what you want. So here you have an example of computing water masks in the same place that we showed before. And you also have here an example of vegetation quality, okay? Examples for how you can build an API, in this case with Fast API, to serve your results, your data analytics, and so on. And on the right is an example of a Streamlit user interface that you can, of course, connect to the APIs that you are building on your own project. Okay, this is also integratable with EOTDL. In the end, we put this slide to justify ourselves to talk about this now. But of course, imagine that you build your data set on EOTDL, you train a model, you deploy your model on the EOTDL. Well, what's the next step? You build an application that takes this model and serves it through an API that you can build an application on top, or you can monetize or whatever. Okay, so this next step is more or less where SPY comes in. And here's some example of applications that we have built with this library. Flood impact, we have the image with different dates. We can identify the water, and then on top of it we can put some open data like a list of schools, hospital, roads, and so on, and we can see which of them are affected and build these visualizations. The same for water quality monitoring. So as you can imagine, this is related to what we showed you before with Scaneo and everything. We are in fact using it for this particular application. We'll also use it for fire risk monitoring, for insurance. Yeah, that's it. Okay, so if you think this is interesting for you, I would suggest you to join our SPY Discord, not the EOTDL one. So through there we will manage also the information. So if you can take a picture at the link, if not, you can ask through email, or maybe in the EOTDL Discord ask for it and I will send it to you as well, okay? So we are testing it with some people, so if you want to try it, then it's also a good time to do that, because we plan to open this in a couple of months. Okay, thank you, that's it.